Just a few words as an introduction. When I was invited to come here, I was in the process to prepare a review paper. And in this case, I asked for a colleague from Australia. Jane knows this colleague. Her name is Dr. Yunusa. And I asked for her some papers, some published papers to include in my review. And we started to discuss ideas about the potential uses of coal fly ash, not the conventional, not the most known one. So after the discussion, we agreed to focus on the possibility to see the use of coal fly ash from the environmental point of view related to carbon sequestration. Because if someone will see in depth the literature related to what fly ash causes when we apply it to soil, can see that there are possibilities to investigate more this issue. So we decided to bring this idea in this meeting and to try if there is a possibility to fix a group, and maybe if it is possible, if we achieve to complete this idea and this proposal, to apply for a research project in the European Union in the frame of Horizon 2020. I think you know all them. So the idea. Okay, thank you.
Coal combustion products, such as there's methodologies for acid sulfate soil analysis. What I've found is that there are a lot of environmental labs in Australia who are environmental labs, but as soon as you ask them anything in particular to test, they go, "Oh, that's not in our, that's not in our scope." And when you're a power station owner, we don't know anything else in terms of where to send our samples to for soil analysis, for example, and to try and have the conversation between the soil scientists or the soil land holders and the power station generators. And I was wondering whether anyone else has come across even just the different types of tests that we would need to do for different types of ashes, and if anyone thinks that that's valid, and if anyone would like to do something along those lines, because we're very disparate. You know, we're all here together, we all know what we need to test, but as soon as we walk out of this room, we're still beset with the same factors. We're still testing heavy metals. We're not testing for anything that tells us about how the plants grow. Was this the forum to ask that question?
Yeah, it's a forum, but Mr. Chairman, because
I think Christos was first. Why don't
yeah,
we
you know what? Let's finish Christos and then go.
Okay. We have to be very, very careful what we're saying here, because they will fall. Okay. A little bit more systematically, the idea that I talked about before is somehow like this: use of the use of the fly ash to ameliorate soil's acidity as a substitute of supplement to the use of agricultural lime, that is conventional treatment of soil's acidity, is expected to obviate emissions emanated from the lime, while at the same time is expected to protect the resident carbon in the soil and increase carbon sequestration through carbonation. Protection of soil carbon due to the ash addition are generally associated with a range of factors such as absorption of CO2 and particulate organic carbon onto ash particles directly or onto unburned carbon within the ash. Second, alteration of soil chemical conditions like pH, C/9, nitrogen, salinity that show microbial and enzymatic mediated oxidation of organic carbon. It is more likely that the net effect could be a combination of several of these factors. The comparative investigation of the potential for soil carbon sequestration of the class C and F ashes, in our opinion, is needed. So it is proposed to be discussed all this, and finally, if we can consider that we can complete an idea for a plan for a project, to exchange our ideas, to exchange our addresses, and to start working on that. And I think the colleague from Australia, Dr. Yunusa, is a very, very effective person on that, because from what I saw in her CV and the papers published in very good journals, I think that she's capable to coordinate an effort like that. This was our idea, and I promised to the colleague to discuss this here, and I thank you once again that you accepted this idea to be discussed here. So after that, I think if someone would like to say something, we can start the discussion and to see how, okay.
I'd like to say a few things about it. First of all, if I recall, Jay mentioned also the matter of carbon fixation, carbon balance. And carbonation is a fact, so, I mean, it's a real issue, or a real item rather. I wonder if, first of all, if somebody actually calculated I mean, the balance. If you have one CO2 on one CaO molecule, how much can you expect? In other words, is this, that it's a real effect, this is certain, but does it make a difference in the carbon balance of the globe? I wonder if somebody did the calculations. Actually, it's pretty easy. So that's the first question. If indeed it is, in other words, if you can show that it makes a dent, you know, in the CO2 balance, I think it certainly is a good item for a joint project, a multinational project. The question is, of course, who to submit it to. I think maybe that's stage 2, because it depends on what countries will participate. Israel and Greece can, of course, submit to the EU, but most countries represented here cannot.
I think they are practical problems that we can see how we can overcome them. I think first to focus on the possibility to agree that there is a field here to set up a good proposal, and after that we will see. I don't know the details. The colleague from Australia told me that it's easy. I don't know all the rules, but probably there are several cases in which we can apply. Okay, I think.
Just maybe I can just add, our Department of Environmental Affairs has just completed a national project determining the carbon fluxes and storages in our whole entire country. Based on that, they're going to propose a whole lot of projects that need to be done. But in our environment, especially the mining environment, carbon taxes is becoming a huge problem. So they're trying to look at ways of trying to quantify how we can improve carbon storage. One of the outcomes, which I could say from the project, is that a lot of the carbon storage is in the soil. It's not the vegetation and things like that. So they have a major effort to try and improve carbon levels in the soil. And by that they can in some way have offsets against the carbon taxes which the mining companies have to. So there's a huge initiative coming now where they're looking at carbon dynamics. And this ties in very nicely with this,
Yeah,
especially with the large volumes of ashes we're going to be using in our mining environment. And this goes to the whole of Africa where a lot of coal mining is going to be taking place.
yeah. Okay. Yes?
2 points. One point is that I mentioned this morning about Dr. Logan's paper in 2000, where he was looking at the fact when he was looking at the pH drop with the mineralization of the organics, he was getting calcium carbonate as a blender, and it was dropping down to the pH of 8.5, which is where the bicarbonate is the buffer point for that. And so one of the points I have is if you're using a alkaline fly ash in there, it would tend, instead of like when you have an anaerobic sediment or anaerobic activity, you're going to get releases possibly of methane or CO2. And with this, you wouldn't. And so that way you could, you're actually holding and sequestering the greenhouse gases with this. And so I think it's calculatable to do that. And there has been work done, and it was on the Enviro project. And so I mean, I really think that that can be done and fairly easily, you know. And you were doing some models.
Yeah, maybe I'll show some slides that I have here,
But
just
being
for the
that-
discussion.
Being that I'm an applications chemist and taught things just like you did, so when you're putting those equations on the board, I exactly know what you're doing. But my point would be, I think it's doable, and I think it's doable without a hell of a lot of money.
Yeah.
I think
Okay.
let's get a few more inputs on this, but I think the whole purpose of this session is to get ideas on the table.
Yeah.
So we've got this one, let's get a few more responses for Christos, and then let's get a few more ideas on the table. I know that Jane had one, Hans had another, so that we have enough time for discussion of all of these. But go ahead, Rami.
Okay.
So maybe I'll give them a very brief overview on one of the issues that it seems to me that still needs elaboration between countries even in order to imply fly ash or enviro in fly ash in field in order to understand better what's going on in it. And I do have some information that maybe can be a jumping point into this field. But it's up to you.
Yeah. Just one comment
Yeah,
from
go
me,
ahead.
and I will finish. Especially for Israeli soils, I think the colleagues from here, from Israel, have to think seriously about that, because from what I know, I read a very good book, The Soils of Israel, I told you before. Most of the soils here are alkaline soils. So we don't use fly ash to ameliorate soil's acidity, which is a common use of fly ash. And the more friendly and the more easy and the more practical. So in this case, here in Israel, we have to think about other uses, other options. One of them is what was presented by the last speaker in the previous session, to use fly ash to enhance soil structure together with materials containing organic matter content. And the other, I think, is this one, to see if we can use fly ash to contribute to the phase of the CO2 release to the environment. So I think for Israel, for colleagues from Israel, it is.
Entirely.
Yeah. Okay.
So with that, what I want to do is, if you have further comments for Christos on it, you can bring it up outside or individually with him.
Yeah.
Jane had an idea she wanted to get on the table. Hans had an idea. There are a few things I wanted to bring up. And then we need to get on to our next session, the panel discussion. So I'm just trying to manage time a little
Yeah,
bit.
okay.
So thank you very much for putting the idea out,
Okay.
and people can follow up with you on that.
Okay, thank you also.
Just a 20-second comment. Christos, maybe I'd suggest that anybody who's interested in getting into a joint project will approach Christos during the next day. later by email and start an exchange, trying to move
Yeah.
the thing forward.
Exactly. Jane, you had a concept you wanted to put out.
Yeah, I was wondering whether or not, I mean, Australia has the coal combustion product handbook, which is generally a review of all of the potential uses for CCPs. However, when we're looking at soils applications, and we're starting to get into the realm of, just back on soil carbon sequestration. I mean, there's a recent paper in 2013 which looks at food security. So we're starting to get into the large agricultural scope. And I don't believe that as an industry, a CCP industry, that we actually have a standard methods for analyses. I don't think it's well defined. There's standard methods for soil chemical methods. I mean, Australia has publications for soil chemical methods, and it seems to be an ability to promote the materials, and it also seems to be an opportunity to discuss the materials, the background of why you need to test certain aspects, and it also would link in with the need to match for soil types. So I was just wondering if anyone else has identified that.
So I think what you're proposing here is potentially a broader handbook on use and disposal of coal combustion residues and what the methods and criteria
Test
would
methods
be. Test
for.
methods.
Yes.
When you
I think just to support what Jane's saying is that when we're adding fly ash to our soils, are the normal soil analytical techniques we're using sufficient? Because you just look at how when we analyze fly ash as such, some of the testing methods aren't always relevant and applicable and give us funny data. So,
well, I think we heard quite a bit today about total content, which is probably irrelevant.
Right.
So that's
it.
So I think the general concept might be useful. I think that why don't we finish the discussion and come back to that, because I think some of the other things, if I second guess what some of the others are going to say, will have some bearing on that.
Okay.
Hans?
What's this? And that.
Okay. Yeah, you mentioned already that all the discussions that we've heard today are based on total content. And that is the poorest property to address environmental issues. Because let me charge it a little bit, because that's the only way to get some reaction. And it's happening, so that's good. No, the point is that when we talk about totals, we get these high numbers, and when you look at what is leachable under normal circumstances, you talk about this fraction of that total. So if you can assess that the quantity of material of a substance that is leachable under environmental conditions, or even exposure by humans, inhalation or ingestion, that those quantities are a fraction of what is totally there, then we may need to reconsider. And if numbers are deciding, or the basis for deciding whether something is good or bad, then I think we have reached the stage where we should get away from that point and use more sophistication in understanding what we're doing. Right now, we see a very strong move towards reuse of materials. Everywhere, Europe, all over the world, there is this drive to use materials. Well, we need to catch up with how we assess that. And you cannot go out and just use materials because you may be doing things totally wrong and create problems for later. And you may not see that now, but that will haunt you maybe 10 or 15 or 20 years down the road. So what is needed is that we have a catch-up process to assess what's going on with those kind of activities. And so we need better tools. And we can't stick with the totals anymore. We need to move forward and have a better understanding. Now, there are tools that can do that. We need to look into the chemistry, the chemical forms, which are important, and there is a major step forward in being able to model, in being able to test, and that's what we need to do. And by doing that, we are in a better stage to help regulators to set new criteria for what is needed and where you should draw boundaries. And let's be clear on that. The whole sector of coal fly ash has a number of situations where we don't want that material to be used in certain applications. Simply because if, I mentioned the example, Nova Scotia has very high beryllium levels in its coal. Well, you don't want to use that stuff. Maybe use it to extract the beryllium rather than something else. And so there are more examples of that. But the majority of the material probably has great possibilities to use in all kinds of applications. So we should stimulate that and create the opportunity to actually do that. But then we need also better tools. Now the nice thing is that when you start testing with more sophisticated tools, you see a lot of similarity. Because when I see results of a single step test, then I see a number. And I have no notion whatsoever what that number means. Because when I get that number, yeah, it shows a level. But I have no understanding how it is affected by when I take that material, put it in soil. Or when I take that material and put it in concrete. No conclusion whatsoever. So it doesn't work. And when I saw Ariel this morning showing the results against the EN test against non-hazardous waste, then you're looking at disposal. But that's not what we're looking for. We're looking for beneficial use. And what is the real circumstance under the use conditions? And there are changes. Material changes with time. Well, we know that. How can you address that? And I think we're at a stage where we have the possibility to understand better. And then that doesn't mean that in the day-to-day practice you have to do all those things, but we need to use that information as a basis to make better decisions. And then take a step back and say, what are the simple ways to verify that this material that I have today from the facility is falling within the range of materials that we've studied and that we know are safe. That's the way to go.
Let me add a comment to that.
Yeah.
Your peg.
That's what it is.
Okay. We heard a lot today about some potential beneficial uses of coal ash in agricultural, soil reclamation, and the like. And we saw some of the benefits that came from it. What we didn't hear a lot about was what the specific concerns are. We heard a little bit about concerns about heavy metals and the like, and general concerns about the potential for uptake or dispersion of potentially toxic constituents that are contained there but may or may not be available. We heard a little brief overview from Pinchas about the apparent benefits without uptake that were occurring in the specific agricultural uses. But what we're not hearing, and I think we need something to go down the path, is a program that defines, based on what we understand of the chemistry, what we understand about coal fly ash, and what we understand about the concerns, that defines a few different things. One is, what are the key characteristics of the materials and the test methods to have them, so that we know those key characteristics. And I think there's a wide body of information to build on previously. The second is defining the limits of what are acceptable ranges for coal fly ash in terms of their inherent properties and their usage rates, their application rates in the field for different soil types, for different potential agricultural applications that would be acceptable. And then what are the monitoring programs? First off, it is not only a monitoring program to enhance the science, which you want to achieve through it, but also to achieve improved public confidence in what is happening. So that means that you need to have quality control programs on the coal ash that you're using, guidance for the applications, and field monitoring programs that say, okay, until there is a decade or so of experience underneath our belts on these things, what should you be measuring in the field that provide both the technical assurance of safety, but also the public confidence in what you are doing moving forward, so that it becomes a routine use. We don't drive cars or manufacture cars without technical standards, without guidance and without safety standards, and without ongoing monitoring of safety, correction, and the like. Similarly, we're talking about a product here that, used properly, has some advantages, and both economically, physically, that are beneficial, economically as well from the products. But also we need a scheme, if you will, a framework that allows us to assure the safety of that product and the public confidence in that product moving forward. And as Hans says, recognizing when you look at the range of coal fly ash, the leachability of different constituents of concern ranges more than 4 orders of magnitude, greater than a factor of 10,000 from one source to another. Some are going to be fine. Some will be very applicable, some will not. You need methodologies and commonalities of how to draw those lines. So I would suggest, where Jane started was with test methods, but I don't think test methods per se are really the goal. I think test methods are part of the picture, but what do you measure, when, how do you establish the guidelines that can be used more broadly, recognizing that it is different from region to region because soil type will be an important factor, crop type might be a factor, what you're blending with it, be it compost or other materials or mine tailings and things like that, and also the geologic hydrologic conditions around you. An arid region and the plant species and the uses are going to be different than a very humid region. So, but a framework that allows you to do that and provides a basis for regulators, that I think we have a few in the room here, that actually can say, okay, this is a way that we understand, we have ongoing monitoring, we have controls, and we have verified out in the field through a regular program that actually what people are telling us today remains true 10 years from now. Because time and time again, you see the best intentions go forward, and with great plans, okay, people run forward, and then they're implemented, and people forgot why they were implemented. And then something changes. It could be the coal that's being used, it could be the application rate, somebody wasn't aware of the background, and then suddenly a mistake is made in the field. And what happens with that mistake? Because of the lack of attention, somebody gets harmed, some property gets damaged, fully preventable by a good monitoring and control program, but at that point it's too late. At that point you've killed everything for a while, the ability to do any measurements, you've lost your benefit. It's almost the equivalent of a plane coming out of the sky. Everyone runs for cover for a while. You want to avoid that by having an appropriately designed program going forward that provides the confidence. That's why I'd say, what Jane is saying, you need to think a little bit more broadly, and we need to hear what the questions are. We need to hear what the questions are from a regulatory perspective, from a public perspective, and from a scientific perspective, and design the monitoring and implementation frameworks around that that provide long-term confidence and checks and balances in the system. Next.
I'm going to expand on it. Not go different, but expand on it. And one of the problems we have is you've been talking about metals because you're looking at the fly ash. Now we add the organics, the biosolids in there. When we get the biosolids in there, we have organics. and there are different organics we're dealing with. And we're really concerned about the hormonal activity. We're looking at what kinds of constituents are in there. You got the pyrenes, which are very, very toxic. You've got phthalates. You've got dioxins. You got that. But the question we have with that is, what are the analytical techniques we would use? If we're using assays, one of the problems you have is we've been doing assays on biosolids for heat-dried stuff. We're going to be moving into other stuff on that. But you have to be able to extract the hormonal material off the sludge matrix to get to the assay. And that is a real problem. And one statement final on this is, you all are thinking, well, I'm involved with disinfection, and I've been dealing with disinfection for over 30 years. And if you realize it right now, we're having the same problem with disinfection. Well, how do we get the viruses off the matrix to be able to say we have it? How do we make sure, I mean, our fecal coliform measurements recently, we found out were way off in the anaerobic digestion process to about 4 to 5 orders of magnitude. So my point is, the analytical techniques, looking at the organics and that, and one final thing is, when you look at coal fly ash with biosolids, there's a big area, Enviro's doing it now. Swing Bioset's done some work where they actually put that in a coal matrix, and they're reducing the sulfur and NOx emissions in an internal treatment. But we have no clue what the chemistry of that is or how it's working. But again, this is the organics part of it, which we've never addressed.
Thank you. I think Ariel's got one comment, then we need to get on to our panel discussion.
To the introduction to the panel.
Okay, good.
I want to give a completely different perspective from Hans and David. I partly disagree with what they said. What I heard from them is again to present applications in the Israeli situation when you would bring coal ash inside the enviro to agricultural soils. In fact, under this condition, you bring small amount of ash per dunam, per hectare, so you don't have to start again a risk analysis when
That's not what I was saying.
characterization. It was I get that we go back to 20 years ago. In my perspective, it's different, and in the open session, I prepared a presentation, but I didn't bring my discount key, so I'll present very shortly. In fact, for our situation, in fact, we are lucky to have full utilization. Now, there is another problem, is optimization. It was on other workshops, it was well reasoned. For example, is it better to use in agriculture, better to use in building, or it perhaps there is still better applications? So I think we have to continue, like our colleague said, we have to look for innovations, and one of these innovative use is to what I call high-tech applications. If even cement production or agriculture is more on the side, I think it's very beneficial, but it's relatively, you don't have to transform your product. You have no preparation, no transformation of the fly ash. You use it as is. When you use it for bottom ash, for example, when you use it for a growing medium, you have kind of transformation. You have to separate particle size. So it's the beginning of transformation. There is another step, what is called by Dr. Craig Aldrich, elaborate elaborate the methods, it's, for example, preparation of zeolites. It was mentioned before that there is a high specific surface area on fly ash. It's an absorbing material, but it's nothing compared to zeolites. Zeolites, in fact, they can be produced from coal ash, and we have a research project in the Ben Gurion University 4 years ago, and there is, in fact, zeolites. These are, once again, it's a thing with its future. It's a place of research, but today it's like a dream. But in fact, you can get another point. Coal ash application to succeed, they have to give an added value. In our world, it's not enough to be, from the ecological point of view, positive. They need to be beneficial from the money aspect also. And here you have the opportunity to transform a material, a byproduct, with cost few euros per ton in thousands of euros per ton. Zeolites are catalytic materials. They are worth thousands of dollars per ton on the market. So if you can have methods to transform, so it's the reason why we had this research project in Israel. The zeolites, one of the applications is to prepare fertilizer, slow-release fertilizer. The zeolite is crystalline materials which are prepared, are found in the nature, in volcanic zones. They can be found in the nature, but today most zeolite materials are synthetic, prepared synthetically. And the very wide application in the industry, and one of the utilization is in agriculture for slow-release fertilizer. Another application is to absorb pollutants in flue gas of power plants for scrubber as a scrubbing material, and even CO2 can be absorbed. It was proposed by the researchers. It can use for soil and water decontamination, and it can be used also as catalyst in the petroleum industry. To transform fly ash, which is amorphous in the nature, to crystalline material, you have to have two steps. You have to solubilize aluminum and silica by acids, and afterward you have to crystallize the silica and the aluminum in the solution, usually by hydrothermal treatment. Is treatment by sodium hydroxide. And in fact, in our project, it was a 2 years project. The first year, we checked the, here I have an image of a SEM micrograph of zeolite. Zeolite is a porous material with aluminosilicate framework, and is specific surface area is between 30 and 900 square meter per gram. So it's very absorptive material, very useful material because it is this high price. And I said that the first year, which was developed a feasibility, check a feasibility from the technical point of view, and there were success. It's possible in the laboratory with few grams, with 3 grams of fly ash to produce zeolites. So the summary of the research project was there is technology to produce zeolitic materials from fly ash. Second point, this technology is able to produce high purity X zeolite with surface area above 400 square meter per gram. And also this technology it uses a sequential treatment with acid and base and hydrothermal solid crystallization for period between 3 and 6 hours. And it was tested successfully for 50-gram batch of fly ash. So once again, it was checked technically. There can be aggregate application from them, and I think it's not economical profitability was not proven at this level by the researchers, but when, like Dr. Sadila said before, I think we have to open all the horizon and to look for more added value utilization.
Thank you. Okay, I want to turn this over to